Hello guys, welcome to Fluid Mechanics 1 class. Today we are continuing the second lab, working on fluid friction apparatus. In the previous exercise I introduced you the unit, and today I'm gonna show the second exercise, the exercise B. So the goal of the second exercise is to measure the head loss when the water flows through the fittings. So there are a lot of different types of the fittings here. So we're gonna measure the head loss only on 8 of them. So we're gonna work with gate valve here and 45 Y fitting and ball valve here, 90-degree T fitting here, and 90-degree large radius bend over here, and 90-degree elbow here. Instead of water manometer, to calculate the heads, we're gonna use sensors. So there is two sensors which corresponds to the levels of the manometer, and they both are connected to the data logger over here, and the third cable is connected to the flow meter, which helps to measure the flow rate. So everything is directly will be sent to the computer. So I forgot to note that also we're gonna measure the head loss of the sudden contraction here and sudden enlargement over here. In this experiment I will demonstrate you how to measure and how to take the readings of the heads from gate valve over here and sudden here, this one, sudden contraction over here. So first of all, we're gonna start with sudden contraction. So this sensor corresponds to the head 1 over here. This one, plug this over in the first tapping. The second corresponds to the over here. Plug this over there. So then open the appropriate system isolating valve here. So only this one should be open, and open the valve here, fully open. Should be fully open. Okay. So let's open our software. Friction apparatus. And here choose exercise B. On the left column you have to choose the contraction, and here so this shows flow rate from the flow meter over here. Here head loss from the sensors over there. So here is elevation 0 and diameter 17, and so valve position is 0. So when we choose contraction, so the valve position doesn't matter. It matters when we choose gate valve and ball valve over there. Here elevation is 0 because the elevation between tappings, the vertical elevation is 0 over here. There is no elevation between them. For example, when we measure the large radius band, so there is elevation between tappings is about like 17 centimeters, the elevation. So when we measure the large radius band, so we have to put here elevation 17 centimeters. So let's start our pump. So make sure it's closed. Turn on our pump, and by rotating the control valve, we will control our flow rate over there. So there is a flow rate, and from the software, you see that the flow rate is right now is 0.16 liters per second. So okay, let's make our first flow rate about 15 or 10. Let's slow down. Okay, right now it's 11, 12. Okay, and as you know, to take readings, just push the go button over there, and here it shows the readings from the heads. Just go button. Okay, so we took the readings for 0.12 liters per second. Let's increase our flow rate by okay, now our flow rate is 0.20 liters per second, and our heads also changing. So let's take let's increase again. It's 0.13. Let's increase again. So approximate increment is 0.05 liters per second. So right now it's 0.24. Let's increase. Here is 25 again. Let's increase again. Okay, so right now it's 31. Okay, good. Let's take readings here. Okay, let's increase to 35. 33. Okay, so right now it's 37, which is 36, 37. Okay, let's slow down. Here we have 35. 35, 36, 35. Take the readings. Let's increase. So the maximal flow rate of that pipe is 0.41. So the 0.41, 42 is the last one. So everything is collected over here in this table, and we will save this, and I will provide you this data. So that's it for sudden contraction fitting, and the flow is limited. Flow rate is limited because as you see, there is a sudden contraction. So the diameter is 17, and here diameter is 8 millimeters. So that's why we have not full range over flow rate, only 0.41 flow rate. But in the valve detail, you're gonna see that the maximal is kind of bigger than from this one. Okay, well, let's turn off the pump. So now we finished our measurements on sudden contraction fitting. Let's take readings for gate valve. So in this software, we have to choose gate valve over here, and valve position. So the starting valve position is 0, and so the sensors are already connected. So the first sensor will be connected to the inlet of the gate valve, and the second one is to the outlet. So the valve is the first position is 0, and the increment of the opening position will be 45 degrees. So the first is, for example, like this one is 0, and then this angle is 45. We're gonna open like gradually by 45 degrees. Okay, so let's turn let's turn on our pump. So there is no flow, as you see, because the gate valve is closed, and here we can open all the system insulating valves over here, because to maximize the flow rate, which goes to the gate valve over here. So okay, let's take a reading for 0 position over here. Valve position is 0. Let's take and change to 45. Okay, let's open the valve at 45 degrees, as you see. So this is 45 over here. So this should be moved to over here. Let's move that. So there we have. So we open by 45. Now the position is 45 over there. There is no still water, like just a little bit. Just a little bit. There is a small water flow over here. Let's take a reading for 45 and change this by 90 to 90. So the increment is 45 degrees. So here, so this should be brought to here. Here, take a reading for my. Let's change to 120. So I change it here the degree by 45. It's a 135, not 120. 135. And here let's move the gate valve here by 45 degree. Now we see that our flow is kind of increasing. Take a reading for 135 here and change by 180. So now the valve is open at 180 degree. Let's take a readings over here. Let's move by 125. So now our valve is, so the position of the gate valve is 225 degree. Let's take a So continue this operation until you will get fully open valve, so in this experiment I have done this for 360 degrees. So now our experiment is finished. Let's turn on the pump.